Hi everyone. In previous video, we studied about the unit cell and the types of unit cell. The unit cell can be classified into two types. Those are primitive unit cell and non-primitive unit cell. As you know, the unit cell may have different structures based upon the 6 parameters. Those are the edge lengths A, B and C and the axial angles. Those are alpha, beta and gamma. Based on those parameters, the unit cell has different structures, and based on that, the crystals can be classified into 7 structures, and those structures are constitutes crystal systems. So there are totally 7 crystal systems are there, and then we study what are the different types of crystal systems and what are the possible variations of the different types of centered unit cell, that is non-primitive unit cell. Whether those unit cells or crystal systems show primitive unit cell or have FCC, that is face centered unit cell, or body centered unit cell, or end centered unit cell. Okay, different crystal systems have certain possible variations in their structures. That is given in this table. Now we will discuss what is given in this table. So here I have mentioned the 7 crystal systems. Okay, so which are those 7 crystal systems? The first one is cubic crystal system. Means the unit cell is having the cubic structure, or the crystal is having the cubic structure. So hence that crystal system is said to be cubic crystal system. If the crystal is having tetragonal structure, then it will form the tetragonal crystal system. This is the second crystal system. The third one is orthorhombic crystal system. Means the structure of the crystal is orthorhombic. And the fourth one is hexagonal crystal system. The fifth one rhombohedral or trigonal crystal system. Then monoclinic crystal system and triclinic crystal system. So these are the 7 crystal systems that is given to you. Okay, and now we will see what is the edge length in those crystal systems and what is the axial angles and what are the possible variations of unit cell and the examples of those crystal system. The first one is cubic crystal system. So here the possible variations are, which can be seen in this crystal system, will be primitive unit cell. So in cubic crystal system, you may have primitive unit cell as well as body centered unit cell and face centered unit cell. So these are the 3 possible variations that can be observed in case of cubic crystal system. Those are primitive and body centered and face centered. Then the edge lengths. How the edge lengths are there in this cubic unit cell or cubic crystal system. So whether all they are having equal lengths or different lengths. So here in cubic crystal system, the edge lengths A, B and C all are equal to each other. Suppose if the edge length of cubic crystal system is 1, that is A is 1, then B's value is also 1 and C is also 1. So all the edge lengths are equal in cubic crystal system. Then what about the axial angles? That is angle between the edges. So those are alpha, beta and gamma. So here the alpha, beta and gamma all are equal to each other and all are having the value 90 degree. Means alpha is also having 90 degree, beta is also having 90 degree, gamma is also having 90 degree. these are the axial angles in case of cubic crystal system. So the some of the examples of this kind of crystal system is NaCl, zinc blende and copper. So remember these examples and especially edge lengths and axial angles for these crystal systems. So second one is tetragonal crystal system. So what are the possible variations? Primitive and body centered. So two possible variations in the unit cell can be observed in case of tetragonal crystal system. So edge lengths in this type of system is A is equal to B, but B is not equal to C. That means if the value of A is 1, then the value of B is also 1. But the value of C is not equal to 1. Either it is greater than 1 or less than 1. Say it may be 2 or less than 1. It may be 0.5 or anything. Apart from 1, it may have any other value. So this is the edge length in tetragonal crystal system. Then what about axial angles? Here also the axial angles are equal and they are equal to 90 degree. Alpha is equal to beta, beta is equal to gamma, and gamma is equal to 90 degree. That means all are having equal angles, that is 90 degree. And some of the examples are white tin, tin oxide, titanium oxide, calcium sulfate. So these are the examples of tetragonal crystal system. The next crystal system is orthorhombic crystal system. So here the possible variations are primitive, BC, that is body centered, FC, face centered and end centered unit cell. And the edge lengths A is not equal to B and B is not equal to C. If you say A is equal to 1, then B is maybe 2 or C maybe 4. So all are having different values. And when we come to the axial angles, the axial angles are all are equal and they are equal to 90 degree. Alpha is equal to beta, beta is equal to gamma and that is equal to 90 degree. And now the examples are rhombic sulfur, potassium nitrate, barium sulfate. So these are the examples of orthorhombic crystal system. Then the fourth type of crystal system is hexagonal crystal system. So in this, the possible variation that can be found is only one, that is primitive unit cell. And the edge lengths here are A is equal to B, but B is not equal to C. And alpha beta is equal to 90 degree and gamma is equal to 120 degree in case of hexagonal crystal system. Okay, see, alpha and beta are equal to 90 degree, but gamma is equal to 120 degree. And the examples are graphite, zinc oxide, cadmium sulfide, etc. Then the fifth one is rhombohedral or trigonal crystal system. So here also there is only one possible variation, that is primitive. Only the particles can be found at the corners. That means, okay. So what about the edge lengths? A is equal to B, B is equal to C. So all the edge lengths are equal to each other. And angles, see, alpha is equal to beta, beta is equal to gamma, and this is not equal to 90 degree. That means these are not having the angle 90 degree. They may have different angles, but all are having same angles. For example, if alpha is having 85 degree, then beta is also having 85 degree, gamma is also having 85 degree. But all these three never have the angle 90 degree. Okay, all these angles are equal, but those are not equal to 90 degree. Other than 90 degree, they have the angles and all the angles in them are same. Then the examples of this type of crystal system is calcite, that is calcium carbonate, HGS, that is cinnabar. Okay. Then the sixth one is monoclinic crystal system. So here the possible variations that can be found are primitive and end-centered. And the edge lengths are A is not equal to B, B is not equal to C. Means all are having different lengths. And angles alpha and gamma are equal to 90 degree. But beta is not equal to 90 degree. These two angles are having same value, that is 90 degree. But beta other than 90 degree, it may have any value. Okay, so beta is not equal to 90 degree. Examples of monoclinic crystal systems are monoclinic sulfur, sodium sulfate, decahydrate. Okay, then the next crystal system and the last one is triclinic crystal system. So here the possible variation is primitive and edge lengths A is not equal to B, B is not equal to C. All are having different edge lengths. And alpha is not equal to beta, is not equal to gamma, is not equal to 90 degree. Means angles are also not equal to 90 degree. And these are also having different values. Okay, if one is having 85 degree, another one will have 95 degree, another one will have 70 degree. Okay, so other than 90 degree, they have different values, and they are also have different values. They are not equal to each other in case of triclinic crystal system. And the examples are potassium dichromate, copper sulfate, pentahydrate, okay, boric acid. So these are certain examples of triclinic crystal system. So this is all about the 7 important crystal systems. Now, when you observe the possible variations, how many possible variations in lattices will be obtained? Totally in 7 crystal systems, if you count this, how much you will get? 1 possible variation, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So there are totally 14 possible variations of crystal lattices are obtained, and those lattices are known as Bravais lattices. So this is the name of the scientist, Bravais. Okay, so he has obtained these things, and hence they are named as Bravais lattices, and there are totally 14 possible Bravais lattices are obtained. Okay, and another thing is, among these 7 crystals, the most symmetric crystal system is cubic crystal system. Most symmetric means when you cut in different direction, you will get the equal pieces. Okay, so this is cubic crystal system because here all the edge lengths are same and all the axial angles are also same. So the most symmetric crystal system is a cubic crystal system. Then which one is most unsymmetric one? So if you observe here, the edge lengths should be unequal and axial angles also should be unequal. That one will be the most unsymmetric crystal system. So if you observe among these 7, the triclinic crystal system, it is most unsymmetric one because angles are different and all edge lengths are also different values. So the most unsymmetric crystal system is triclinic and the most symmetric crystal system is a cubic crystal system. So this is all about the 7 crystal systems and 14 Bravais lattices. So remember these edge lengths and axial angles because these are very important for the competitive examinations like CET, NEET, JEE, as well as in theory also it is very important.